Have you ever wondered what happens to satellites after they stop working? Let's take a step back in time, to the year 1957. The world was caught in the throes of the Cold War, and the space race was just beginning. The launch of Sputnik 1, the first man-made satellite by the Soviet Union, marked a significant milestone in human history. This marked the humble beginning of our journey to the stars. Over the decades, satellites have evolved from simple transmitters orbiting the Earth to complex machinery that aid in communication, weather forecasting, navigation, and even spying. They've become an integral part of our daily lives, often without us even realizing it. As of now, there are thousands of satellites orbiting our planet, each with a unique purpose and destiny. But life for these celestial bodies is not without challenges. They face a multitude of issues, from the simple wear and tear of operation to the complex process of decommissioning once their useful life ends. And let's not forget the ever-present threat of collision with other satellites or space debris. So the next time you look up at the night sky, remember that it's not just stars you're seeing. There's a whole fleet of human-made objects up there, busily transmitting data and keeping our world connected. With thousands of satellites currently in orbit, the sky above us is busier than one might think. Yet, despite their technological advancements, satellites are not immune to the dangers lurking in the cosmic realm. In the vast expanse of space, orbiting satellites constantly face perilous risks. One such risk is space debris, remnants of defunct satellites and spent rocket stages, which whiz around the Earth at high velocities. Even the tiniest piece of debris can cause catastrophic damage upon collision. In addition to space junk, satellites must also grapple with meteoroids, fast-moving rocks hurtling through space. These unpredictable visitors pose a real threat to our celestial sentinels. The harsh conditions of space, with its extreme temperatures and high radiation levels, further test the resilience of these satellites. A case in point is the infamous collision of Iridium-33 and Cosmos 2251 in 2009. This event underscored the vulnerability of our satellite infrastructure, emphasizing the need for better space traffic management. Indeed, space is not as empty as we often perceive. But the threats to our orbital guardians are not just physical. Have you ever heard of solar radiation explosions? These are massive bursts of solar energy and magnetism, catapulted from the sun's surface into space. Imagine 1 billion nuclear bombs exploding at once, sending shockwaves of charged particles hurtling at near light speed. This is the power of a solar radiation explosion. These eruptions have the potential to wreak havoc on Earth. They can cause geomagnetic storms that disrupt our power grids, interfere with satellite communications, and even damage our electronic devices. One of the most significant events in recorded history is the Carrington event of 1859. This solar storm caused telegraph systems across Europe and North America to fail, even sparking fires in some telegraph offices. A solar radiation explosion could turn our technological world upside down in an instant. Just imagine, one day you're scrolling through social media, and the next, we're back in the Stone Age. It's a cosmic challenge we can't afford to ignore. Faced with these challenges, how do we protect our satellites and by extension our modern way of life? It's a daunting task, but one that scientists and engineers around the globe are tackling head-on. They are the silent guardians of the sky, constantly innovating to shield our satellites from a myriad of threats. One such innovation is space weather forecasting, akin to our terrestrial weather predictions, but focused on solar activity. These forecasts help predict solar storms, giving us time to safeguard our satellites. Then there's the robust design of the satellites themselves. Engineers work tirelessly to create satellites that can withstand the harsh conditions of space, from extreme temperatures to the threat of space debris. These efforts, among many others, are helping to ensure the resilience of our satellite infrastructure, thus preserving our modern way of life. Our guardians of the sky are more prepared than ever to face these cosmic challenges. As we've seen, the journey of satellites is an incredible yet perilous one. From the pioneering days of the space race to the modern digital age, these celestial guardians have been critical in shaping our world. Yet, they face significant threats from space debris to cosmic solar radiation. So, the next time you look up at the night sky, remember the silent sentinels orbiting above us, protecting our digital world. It's a testament to human ingenuity and a reminder of our delicate dance with the cosmos.